Okay, started.
স্যার একটা কথা বলুন, জ্যাকার্ড সিমিলারিটি, ঠিক আছে,
Hmm.
আর জ্যাকার্ড ডিস্টেন্স, আর দে সেম?
No, no, no. They are like, in a sense, complements of each other. So, similarity meaning similarity is a score. So, what does a similarity mean? Similarity means that if two things are more similar to each other, or in some sense, if they're closer to each other, then that will have a higher value, right?
Okay.
When you are measuring similarity. When you are measuring distance, if two things are farther away from each other, then they have more distance, then they have a higher value. So you see, in one case, the value increases if things are closer together. In the other case, the value increases if things are farther away from each other. Right. So Jacquard similarity is basically Jacquard formula is what? Intersection by union.
Intersection upon union.
Yes. So intersection is a measure of similarity, right? But the more similar two things are, the more intersection they will have. And so that formula is for Jacquard similarity.
Okay.
Right?
And if they are asking distance, so I have to do 1 minus that similarity.
Yes. Why 1 minus? Because Jacquard similarity can have maximum value 1.
Probability. Understood.
Right.
Fine. এই ছোট ছোট কোশ্চেন জানো, আমি আরেকটা কোশ্চেন আছে।
You sent me a mail. Should we discuss that or not?
That will be discussed, sir. মানে এই ছোট ছোট একটু theoretical কোশ্চেন আছে।
Okay.
অ্যাসাইনমেন্ট 3 তে কোশ্চেন নাম্বার 10 দেখুন তো, বুঝি আমি বুঝতে পারিনি।
Okay, let me just open this. Okay.
আপনি কোশ্চেন নাম্বার 10 টা করুন।
You have a collection of sets S1 to Sm, each of size n. Suppose for each set Si, you define a hash of the set by picking an element of the set at random. Fine. HSI is a uniformly chosen element of set I. Okay. So the size is fixed and the hash is basically selecting a location at random, right?
Okay.
Uniformly at random, and whatever the element is there at that location, it is picking it, right?
Okay.
Now, will T of HSI equals to HSJ for two sets be equal to Jacquard similarity? Right. So this is a nice tricky question, but the answer is correct. So you are getting what? So you know the Jacquard similarity of two sets can be any value between 0 and 1, right? Okay. So now let's say you have two randomly shuffled sets. Okay. What is the probability that if you pick any of the one of n positions, the elements will match?
1 by n.
That. So basically what it is saying that if you have a random shuffling of, so basically let's say you have a set with n elements, 1 to n. Now you randomly shuffle it and create a new set. Okay.
So it doesn't matter. If I shuffle it, so it doesn't matter. Set is the same.
The set remains the same. So the Jacquard similarity is 1, right? Amongst those two sets, because they have the exact same elements, but in different shuffling orders, right?
Yes.
Okay. But imagine that you had initially 1 to n, and now you are randomly shuffling n in the new set, all n items. Now, what is the probability that at any location it will match?
1 by n.
1 by n. So it is not equal to Jacquard similarity, right? So that is why C is the correct answer.
Can be independent.
Yeah, Jacquard similarity does not influence the outcome in any way. So here the sets were completely overlapping, but still the probability of a matching under some random shuffling is 1 by n. So option A is also no, but that is specifically giving you a formula, right? That equal to the size of the smaller set by the larger set. No. So
that's
we
not
have
a-
a counter example here.
not a-
So yeah, so basically C is correct because of that.
अच्छा, ठीक है, ये तो ठीक है, मैं एक बार और पढ़ूंगा।
No, matlab, you have some doubt in this? Let's clarify it now because you don't.
क्लियर नहीं है, क्लियर नहीं है, बात मींस आई डिडंट गेट, मतलब क्या बोलूं, वो उतना ये नहीं है।
So basically, okay, so are you convinced that if you have n elements, 1 to n, and then you randomly shuffle them, the probability of
1 by n, ये तो पता है मुझे।
this is clear, right?
हाँ,
So basically, if you have Si and Sj and they have the same elements, the probability of same value in the same position will be 1 by n.
हाँ, ये भी clear।
This is fine. And Jacquard is 1 in this case.
Huh?
Jacquard is 1, right?
Jacquard is 1.
Yes. So the Jacquard value has no relation to the collision probability here. What is PHSI is equal to HSJ? That is the probability. That has, so basically in min hash, basically what do? We say that P of HSI equals to HSJ, which is the collision probability, equals to Jacquard, right? So this is in context of min hash, by the way. So min hash is a way for hashing these sets where you have a global permutation and then you pick the first element, that thing, right? So there our PHSI equals to PHSJ equals to Jacquard.
Fine.
That we have discussed before. But in this case, this has no relationship to Jacquard.
अच्छा, समझ गया।
So it is in context of that.
Be equal नहीं हो सकता, maybe, but it's not.
It may be, it may be not. So basically, independent means that there is no relation between the two. We are not saying it's definitely not equal. It can also be equal, who knows? So if the two sets do not have any element in common, then intersection is 0. And also the probability of any two positions having the same number is also 0. So there it's equal. But in this case, it's not equal. So, I mean, we cannot say anything.
Okay. Sir, assignment 4. You have discussed that question again. I am asking. Some question is there related to that. Assignment 4. ये question 1 आप देखिए, question 1 ऊपर जाइए। ये question 1. M by 2. That at the end, frequency. Okay, it's fine. I agree with. From where this 2 came?
Which 2?
The M by 2 answer. The M by 2.
This.
M by.
This you are asking, which I am highlighting.
M by 2. ये वाली. Who cubed? M by k होता ना? K का value तुम्हारे.
No. So I basically K is the number of counters. So it will be M by K plus 1 then. I mean, so M by 2 is, so do not think of it as the form. So M by 1 is what? M by 1 means M. So how can the frequency will greater be M? Sorry. When you put, if you say this is M by 1, then frequency will be greater than M. But how can that be? We have total M elements, stream of length M. So frequency will have to be less than equal to 1, right?
Okay.
That is one thing. Now imagine that we have a array. I mean, apart from the formula, we'll see what the formula is. But apart from that, we have a, let's say, array of length M. And there is a majority element there. Majority meaning that element occurs more than M by 2 times. More than half of those elements are same, right?
Okay.
That's what this is saying. Frequency is greater than M by 2. Means more than half of the elements are the same value. So with only one counter, which is k equals to 1 is only one counter I am keeping, we can decide the frequency, the item with the highest. That's what it is saying.
Who said that more than half of the values are same?
Yeah.
More than half of the values are same. Where is it in the question, sir?
No, so whenever it's asking, so in the question, what is it asking? That we have only one counter and we have a M length, let's say array, stream is array, nothing else. what should be the frequency of an item? Item is what? Item is every item in the stream. So frequency of item is how many times that item occurs. And it's asking how many times should it occur so that at the end this counter can identify it. So that is like so that is another way of saying the same thing is, so basically the question is telling you the frequency of the item should be greater than m by 2. Another way of saying
question number 4, ये भी related question नहीं है. Question number 4 पे जाइए.
Okay.
हाँ, आप जाइए. आप पढ़िए थोड़ा.
So yeah, so here I think that formula comes in, that in Mishra-Gress, if you have k counters and 280 elements, then what is the frequency? What is the frequency required for an element to be guaranteed of being present at the end? So here there was that alternative algorithm, right? Where every time we have a new element, if that has not been seen before and there is a counter free, we update that counter and store it. Otherwise, we subtract from everything. That Mishra-Gress was there. So there, I think this formula came. So this is m by k. So the first one was basically Mishra-Gress is a generalization of the Moore's voting. Sorry.
Specific algorithm.
Yeah. So what I'm saying is, Mishra-Gress is a generalization of the majority voting algo in question 1.
Okay.
So for only one element, we can do with one counter for m by 2. That's the thing.
Okay. Otherwise, so this is fine. Okay,
this fine. Formula, otherwise you apply.
Okay, clear. Next one is fifth one.
Okay. So here what? M is same as before. Now here they are saying that elements with true crowns, which means basically frequency should be more than 6%, right? 6% is what? 6 by 100? 0.06. So I think in the slide there is that formula k equals to 1 by epsilon.
K equal to 1 by epsilon.
Right. So from this you will get the value of k is 1 by epsilon, which is 1 by. So here this number does not matter.
Okay.
Why this doesn't matter? Because we have a percentage here. We are talking about percentage frequency.
Okay.
So it can be percentage of any number. Doesn't matter. Okay. But if this percent, so if k equals to 1 by epsilon you use, you can get that value.
So sir, how will you get 17? How 17 is coming?
What is 100 by 6? I'm not sure.
100 by 6. 16 here.
16.6666.
17. I say 100 lily.
Yeah. So that is that. 1 by epsilon is k, right? You are asked the number of counters. Number of counters we know is k. Right? And k equals to 1 by epsilon we know. And epsilon is 6 by 100.
Okay. Take it. Clear. एक theory question is 7 वाले.
Okay, I haven't seen this before. Let's see. Let A be a matrix with m rows and n columns. Your goal is to pick a subset of A. Your friend gives you a S matrix and says if you multiply A with S, then you get a subset of C columns. Fine. What do you think of the structure of matrix B? Okay, so basically what the friend is saying is that if you multiply A with S, then you will get subset of C columns, right? Yeah, so you have A and your friend is giving you a matrix S, which is designed in such a way that if you do AS, you will create a subset of the columns of A, right? So matrix multiplication, if you remember.
अच्छा समझ आ गया, क्लियर हो गया. उसका मतलब जब वो एस दे रहे मुझे और वो मेरे सबसेट हो रहा है, उसका मतलब मेरा जो मैट्रिक्स दे रहा है वो 1 और 0 वाला देगा, जिससे क्या होगा, मेरा बाकी सारे एलिमेंट 0 हो जाएगा और कुछ एलिमेंट्स मिलेंगे जो सबसेट होंगे इस मैट्रिक्स.
So the way of thinking is you have initially a matrix of shape m cross n, right? And what the claim is that you have a matrix of shape m cross c. AS is a matrix of shape m cross c, right? because it is creating a subset of C columns. So columns changes from N to C, but the rows remains the same. That's the claim, right? So what should by matrix multiplication the shape of S be? The
N cross C.
N cross C, exactly. So that's your first hint, that S should be N cross C. And then you have to see like which of the options gives you zeros and ones in such a way that it picks the columns.
अच्छा अच्छा समझ आ गया समझ गया ठीक है ठीक वन सर एक बार ये स्टेटमेंट पढ़िए सर करेक्ट आंसर this is a matrix with n rows and c columns ठीक है and each column of s has only one entry as one
right
other entries why one entry is one
has only one. So imagine you have a column m cross sorry a m cross n and you have a s n cross c where each column has only one. Okay, so what will happen if you multiply if you do the matrix multiplication, that whatever one is there, that will select the corresponding column. I mean, if you just write it out in a small matrix, you can easily see what's happening. So
only one, actually I am getting only one element. If you say I'm getting only one element of the matrix, original matrix, my original matrix.
So, okay, so let's say S is a column vector. Okay, S is a column vector with all zeros except only, let's say the first position has one. Okay, okay, just for simplicity. And
I'm writing also.
Yeah. So let's say S is a column vector where the first position is, so let's say second position is 1. Let's make it a bit non-trivial. So 0, 1, and let's say 5 zeros. Okay, that is S. Okay. And now A is a something cross 5 matrix, right? Okay, so you are getting it right. So it will repeat for every column, basically. So I think the trick to these questions is to just have a very thin one, like single column S, and see what the values need to be.
Actually, it's a statement. So much time actually. The way they have written.
I see. Yeah. Okay.
आप चलिए सर चलते हैं आपके क्वेश्चन असाइनमेंट नंबर 5
आपके so what do you mean, that doc that you shared or
आ गया असाइनमेंट नंबर 5 में वो सारे क्वेश्चंस आ जाएंगे डॉक एंड एवरीथिंग
I see. Okay.
Seven. These are all drop questions.
What is this?
Construct a Hadamard matrix, normalized Hadamard matrix. X64. What is the minimum and maximum singular value of the matrix?
Okay, so I have not seen this before. Let me read it. Construct a unnormalized Hadamard matrix A64. What is the minimum and maximum singular value of that matrix? Okay, so 64 is, so let me just see, Hadamard matrix.
Formula है तो ठीक है मैं भी भूल गया वो formula है वो कुछ बताया था लेकिन हाँ ये है
Okay, got it. So yeah, so 864, how to construct is this formula. So you have 1 year, you start, it is a recursive procedure. So you start, let's see, we start with a 1 and then we replace, we put H1 here and get H2. So 1, 1, 1 minus 1. And then this H2 is basically here, H2, 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 and then minus of H2, right? So this is H4. So 64 will have 64 cross 64 rows and columns. Right. So this is the Hadamard matrix. And then what are they saying? So now we know how to construct it. So let's see the question. Unnormalized Hadamard matrix of 64. What is the minimum and maximum singular value of the matrix? What is the singular value? Let's see. Okay, for any RN, this be the Euclidean length of the column arranged Euclidean lengths. Okay. Then similarly by this n by n complex matrix. So similarly for matrix.
This is
Let's
not the explanation.
no. Yeah, wait. I think it is a general concept. No, this is showing SVT. No. So I think the first one was right. Hold on. Yep. So this is what. Let sigma 1, sigma n be a singular value, x1 divided by main diagonal entries, not this. Okay, here we have something. Around matrices result that 2 norm is used in the product equation. This thing relationship is HXF. Let's search for a minute more and then we'll see the question.
Sir, I got the answer. I got the answer.
Where is it?
Sir, it is the answers only. ठीक है, अभी मैंने पढ़ा वो explanation is very good. वो देखिए आंसर.
No, so basically what I get it. So if we take the norm of each of the columns, then we have 64 sequence of +1 and -1, right? So what would the norm be? It would be like 1 square plus -1 square plus something 64 times, which is basically 64, right?
Yes.
And square root of that is 8. So basically I think what they are saying is all the norms of each of the columns are the same, and so all of them will be equal to 8. Do you remember the formula for L2 now?
L2.
Hmm?
L2, yes, sir. Root over x1 minus x2 whole square plus y1 minus y2 whole square.
Yeah. So if you have x1, x2, y1, y2, but if you have only x1 and x2, then you consider the other to be origin, and it will be just x1 square plus x2 square root of that. Okay. So that's what is happening. For every column, it has a sequence of +1s and -1s.
Yes,
and
sir.
if you do the L2 now, that is square of everything as summation and then square root of the sum.
Okay.
Right.
One more question is there. Next question, the next.
Leverage score of each row in I10 is 1. What is the leverage score of 7 into I10? So I think I remember what the prof had said in this. So leverage score is basically you are taking the norm of each row and then you are just computing a normalization over all of them, right? So in identity, every row has only one single entry with 1 and everything else is 0. So what would be the L2 norm of that?
Everything else, one answer.
One. So every row has 1. So you have, let's say, an 10 cross 10 identity, you have 10 ones, right? Right. So normalization is that. So basically, if you have the leverage score of rows 7 into 10, 7 into 10 means that you are just multiplying the 1 to 7, right? Right. So if you are scaling a matrix, then the positioning of the matrix does not change, and the basis does not change. So what it is saying is you have 7 in each of the positions, and therefore every row has the same constant value. Instead of 1 earlier, it has 7, and therefore the normalization will give the same result. I mean, the distribution will be the same. So if you have 1, so it's basically uniform, right? Earlier every row had 1, now every row has 7, but the probability distribution you can think is that the same. It's unchanged because it's a constant value everywhere. So there is no formula for this. So I think if you watch the lectures, it will
Sir, I've gone to the lecture, I've gone to the YouTube, Google, everything. I didn't get any formula. Formulas will be there.
Okay, that should be there. Mhm. So something is here randomized. This video is coming up. Our NPTEL video.
Wait, into ये देखिए पढ़िए.
Mhm. Okay, so for example, here it's written that for any n cross D matrix U, okay, can you see this?
सर एक zoom करो. हाँ, ठीक है sir. Yes.
For any n cross D matrix, if you define a function Li, where Li is Uij square of that j equals to 1 to d. So basically for any ith row, it's taking summation over all j and it's summing the squares, right? So what we have been doing for any identity, let's say we take the 1 square plus 0 square, 0 square, 0 square for every row. And then it's taking a sampling matrix. What is the leverage code definition? Nope. This is after that, it's not giving additional info. Leverage scores of a full column matrix A are the squared row norms of the basis of range A. I see. Okay, got it. Fine. Okay. So here the definition of leverage scores is this. So this is probably there in the lectures, but let's clear it now. Leverage scores is basically for any full rank matrix A, these are the squared row norms. So squared row norms we have discussed how to take it, but squared row norms of which matrix is the orthonormal basis of the A of the matrix A, right? So what is an orthonormal basis, or it's not
Sir,
clear?
I forgot it. I know, sir, but I forgot.
Okay, so first of all, I10 is identity in 10 dimensions, and that is a full rank matrix. Okay. Why? Because it has 10 independent bases, which are the orthonormal bases. Orthonormal meaning that they are perpendicular to each other and they are independent. So basis means that set of the basis defines the subspace. So basis, all the vectors in the basis would be linearly independent of one another, right? So here in identity matrix, if you take any of the rows, they are all like, they have ones in different places, right? So the dot product between any two of them would be 0.
One. One dot one. Sir, one only, sir.
Any two rows. What is the dot product between any two rows?
Any two, sir, सारे में one है, total one है. One.
नहीं, identity is bro. Identity.
अच्छा, okay.
Be very clear
Diagonal,
about the definition of identity because it's like a basic thing.
Diagonal is 1. 0. The value is 0.
Yeah, diagonal is 1. Okay, you are clear about. So how are you computing norm then? So identity is diagonal is 1, everything else is 0. This is write it down in stone. Okay. Now,
That I know science.
okay. So now if you take any two rows, then they are independent. Are you convinced about that?
They are independent.
Yes, because you cannot express one in terms of the other. They have ones in completely different dimensions, different locations. Okay, so they are independent and also they are normal. Why they are normal? Because their dot product equals to what?
0.
Dot product is 0. 0 means cos theta is 0, which is 90 degrees. That means they are normal, right? So identity matrix has a orthonormal basis of 10 vectors, right? Why? Orthonormal because they are pairwise independent and normal to each other, right? So now if you just multiply it with 7, then does the orthonormal basis change? Here's the question for you. What does multiplication with 7 do? It will replace all the ones with 7, right?
Yes.
Zeros will remain as zeros and the ones will become 7.
7.
Okay. So now, are they still independent? So,
Yes.
okay, here's the question. Is the 1, 0, 0 vectors, are those still the orthonormal basis for this 7 into I10?
Okay.
No, I'm asking you a question. What do you think?
1, 0, 0.
1, 0. So I10 had a orthonormal basis, right? You had a set of 10 vectors, right?
Understood. Clear.
So let us call them E1 to E10. Okay. E1 is what? A vector where the first position is 1, everything is 0. E2 is second position 1, everything else is 0. So E1 to E10 are the 10 rows of I10. Okay.
Okay.
Got it?
Okay. Fine. Clear.
Okay. Now E1 to E10 are the basis for I10, orthonormal basis that we have discussed.
Yes.
Now the question is, are E1 to E10 a valid basis for 7 times I10?
It's valid.
It's valid?
Yes.
Okay, because you can use those E1 to E10 to express 7 I10 basically. 7 times E1 plus 7 times E2 plus all that. So the orthonormal basis is unchanged. This we have established. The orthonormal basis does not change. And like we saw, the definition of leverage code is that given the orthonormal basis, it will compute the squared row norms of them. So squared row norms is basically what we have discussed earlier about a square plus b square plus square root. So since the basis is unchanged, the leverage score is also unchanged.
Okay. That means that will be 1. Simple.
Yes.
Okay. Yes, sir. Clear. Next question, sir. 9.
So 96 cross 6 matrix by stacking 16 identity matrices of size 6, 6, one over the other. Okay. What will be the leverage score of each row? Check by implementation or intuition is creating copies of the rows distributes the leverage score over the copies of it. So 1 by 16. So the shape of the matrix is clear. You have 6 by 6 identity matrix.
Of 16. 6 plus 6.
Right. So you have like 1, 1, 1, 1, 1, 1 in the diagonal for the first 6, and then again you start at 1. Okay. So what they're saying is you have 16 copies of the same row. Okay.
Yes, sir.
Like one E1, basically what we discussed earlier, E1 here would be 1 and 5 zeros, right? And E2 would be 0, 1, and then 4 zeros, something like that. Now there are 16 copies of E1 in the rows. So what they're saying, since there are 16 copies, the score will be distributed amongst them. Leverage score 1 by 16.
It's fine, sir. You clear it. Sir. Yeah, sir, can I share my screen? मेरे पास old paper में कुछ एक दो question है वो मुझे पूछना है old papers
Okay,
छोटे छोटे you know those questions we have already discussed एक doubt है कर छोटे छोटे
which one? मतलब should I stop presenting or will you share the paper?
सर आप first please week 8 में एक बार देखिए तो week 8 का solution भी आ गया नीचे जाइए सर मुझे d square x by d एक क्वेश्चन था नीचे d square
Question number बताइए।
अच्छा सर ये सर थोड़ा सा मैक्सिमाइज करेंगे मैं थोड़ा देख लूँ
Okay, let's go one by one. 1, 2,
चलिए नीचे चलिए ओके फाइन आगे नीचे चलिए सर सर पहले तो ये बताइए सर फिफ्थ वाला क्वेश्चन क्यों मेथड ऑफ मल्टीप्लायर है follows from the lectures
So we had discussed this before, nahi? Okay.
but we discussed that this is dual decomposition the answer is method of multiplier
No, this is, oh, that's what we discussed. Okay. No, basically okay, so
x को अपडेट करके हम x को अपडेट करके हम z में यूज ही नहीं कर रहे we are using it on y update of x
yeah, I think that's a typo then. So
typo.
yeah, so let me get to the slides. It's easier to discuss it from the slides.
No sir, both the equations are different. Both the equations are different.
No. So what I'm saying is this is what they're talking about, right? This is ADMM. If you just ignore that XK business, then this is exactly what is there. Let's see. Like you are first changing x, so zk yk is fixed. You are first changing x to xk plus 1. Okay,
fine.
So one sec, yeah, so zk yk is fixed. You are first changing x to xk plus 1. Okay, now so yk and xk plus 1 is fixed, and then you are changing z to zk plus 1. So what here is happening is yk and xk they are written. If you consider this xk plus 1, then they are changing z to zk plus 1. So apart from this one inconsistency, rest is the same. Okay. And then the last is basically what is happening?
Something different in this.
No. Yeah. Okay, then you are doing xk plus 1, zk plus 1, like you have now decided the values of xk plus 1 and zk plus 1, and then you are updating yk, right? So what you're doing here, you have decided the values of xk plus 1, zk plus 1, and you're updating yk. So this is exactly the same, right?
Typo error.
Typo. So basically these are ADMM update equations for fx plus gz given ax plus bz equals to c. Sorry, I am having some problem. Okay. So this is also ADMM problem for fx plus gz subject to x plus bz equals to c. Okay. So this is it. But the thing is that why is this method of multipliers? Okay. That was the basic question. So for that, you just need to have this picture in mind. Okay.
No, sir, that I'm not asking.
Okay.
My question was, please go to the question. ये तो मुझे दिख गया यहाँ पे ये है.
Okay.
Question में जो x के जो है x के होने के बाद मैं that's why I gave the wrong answer. Dual decomposition. Because of this typo error, I have given a wrong answer. Dual decomposition.
Okay.
Yeah. So what I'm saying ये ठीक है method of multiplier तो clear हो गया वो मुझे clear है उधर वाले ठीक है मैंने सोचा x के करके क्या changes डाले something might be there I thought something else some other point might be there that's why I asked you this question it's clear this question is clear
okay
now ইন্দ্রজিৎ স্যার এই করবা এখানে যখন এই টাইপো এরর ছিল আমি এটার জন্য 0 পেজ পেতে মার্কস পাবো আমি
I don't know, so we have to see.
মেল করে দেবো নাকি এটার জন্য
Yeah, you can point out that there is an inconsistency between what's there in the slides and what's there in the question.
Okay.
So maybe they will consider this question.
Okay. Sir, please, I will share the screen now.
Okay.
No. One six actually.
Hmm.
NPTEL. Yeah. What कल पेपर है कौन सा Can you see the questions?
Mhm.
Can you see the questions? Okay, welcome. So this question.
Hmm. So this is something is wrong here because F1 score can always be between 0 and 1, right?
Yes, sir.
Do you know that?
That I know, sir, but it's for possible, sir.
Hmm?
It can be between more than 0 and 1. It can be between, say, are you told 2 cross 2 elements, 2 cross 2? Yes, no, like that. Yeah.
Mm-hmm.
But it can be more also. I have seen it somewhere.
F1 score can be more than 0.
It can be.
I don't think so.
It is there, sir. It can be more than 3. See, 3 cross 3 is there. 2 cross 2, 3 cross 3. Miracle exam last.
One sec. Hmm. I don't think so. But okay, let's solve this question. I'll tell you what answer I will get. That will select the right answer for you anyway. So, see, here's the thing. What is the formula for F1 score? It doesn't matter if it is binary, multi, whatever. What is the formula for F1 score? 2 into precision times recall by precision plus recall, right? Do you know that formula?
Yes, sir. But how to find the precision there?
No, that is, we will come to that. But are you convinced about that formula?
I am convinced, sir. I
Okay.
get it.
So
I get
what is the maximum value precision and recall can each take?
it. Sir, I do not know.
So precision and recall can be at most 1. It is like written in stone. Okay. It cannot be greater than 1. By definition, it is not possible. Okay. Precision is what? Precision is amongst the suggestions of your models, how many of them are correct, right? So the fraction of correctness of your model. So that cannot be greater than 1. It's a fraction. And recall is amongst the total number of correct things in the world, how many of them were your model able to identify? That is also a fraction. So precision and recall cannot be greater than 1, and therefore F1 score being a formula 2PR by P plus R, if you put P and R equals to 1, then that is 2 by 1 plus 1, which is 1. So F1 score cannot be greater than 1. That's the first insight. Okay. So now here, let us compute. So you have to write down a bit if you have access to something. I'll tell you what values I am putting and how. Are you ready?
Yes, sir.
Okay. So they are saying that we want to look at B with respect to B. Okay. So now in the actual columns, it's saying that total B has 2000 items, right? Is that right?
Yes.
Okay. So amongst those 2000 items, the model or whatever has put 400 into A incorrectly and 400 into C incorrectly and 1200 into B correctly. Okay. So that means, so from this, what can we get? We can get the recall, right? So what is the definition of recall? Amongst all the correct items, how many of them were the model be able to identify? So more precisely, let's go to the precision recall formula. So you know the concept of true positive, true negative, false positive, false negative?
Yes, yes.
Okay. So for B, how many true positive are there? Can you tell me the number by looking at the table?
1200.
Yes. So let us please write it down. TP equals to 1200. Okay. Now we know that 800 have been incorrectly put in A and C, right?
Yes.
So what is that? It is amongst those TP, FP, T, and F1. Which one is that? Can you think of it?
False positive.
No. Why would be false positive? You are saying that, so anything that is assigned B is positive, anything that is not assigned B is deemed negative with respect to B. So they have been falsely classified as negative and hence put in A and C, right? False negative. So what is the value of false negative?
400. 800.
Yes, 800. Okay. So TP equals to 1200, FN equals to 800. Please write it down. Okay. So you are convinced till now, right? TP and FN. Now, what is the formula for recall? It is, you can search it online, but I'll tell you now. It is TP by TP plus FN. Yeah. So true positive by true positive plus false negative. So true positive is the number of items that have been correctly classified as positive, and false negative is the number of items that have been falsely classified as negative, right? And this is the total number of items in set B, right? 2000. So what is recall? Can you compute the value of recall?
3 by 5.
3 by 5 or 0.6 for easy computation. We'll consider it 0.6. Okay. We have one item amongst precision and recall. We have computed recall. Now for precision, the formula of precision is TP by TP plus FP. Okay. You can check it online again, but for now you can write it. TP by TP plus FP.
Okay.
Okay. We know TP. Now we want to find FP. Okay. Right. So now false positive. So now you look at what is false positive? False positive is the items that have been classified as positive but falsely. That means those items are actually negative, but they have been called positive by the model, right? So prediction of the model. So now you look at the prediction row. What does prediction row of B tell you?
24.
Right. So total 2400 items have been classified with B or clustered with B in this case. But amongst them, only 1200 are actually B. The rest are false, right? So what is the false positive count?
1200.
1200, exactly. So what is the fraction? What would be the precision value be?
1200. 1 by 2, sir.
1 by 2, or we will call it 0.5. Okay.
Yes, sir.
So now you can put the formula and get F1. Let's get F1. What is F1? What is F1 score? You have P and R. So you have P and R, and you have the formula that F1 equals to 2PR by P plus R, right?
2PR by P plus R.
By P plus R.
P plus.
Right? So what would F1 give you?
2PR. Sir, please tell me the formula again.
2PR by P plus R.
Yeah. Is precision. Precision is 0.5.
Yeah.
0.5 plus recall. Recall is 0.6. 1.5.
Tell me as a fraction.
1 by 1.1.
Mm-hmm.
1 by 1.1, 10 by 11.
The formula again I will tell you, 2 PR by P plus R.
Okay, fine. So 10 by 11.
What is your numerator?
10, 1, 0.
How did you get it? What did you multiply in the numerator?
0 into 0.5.
So where is R? 2 PR.
Okay, 2 into R. R is 1.
Mm-hmm.
0.6. And 6 by 11.
So
It's 6 by 11.
accordingly, the answer according to me should be 6 by 11. I think the by 11 is missing, but they have marked D, which is 6. I think from all the options, by 11 is missing. That is my answer to this question. F1 cannot be greater than 1.
That's it. Okay.
But the most important thing is the formula. I mean, the formula is okay, but seeing the table, you should be able to identify TP, FP, FN, TN, all that. Are you convinced about that or?
Okay, leave it. Karthik is a fine, sir. I'm convinced.
Okay. Hmm.
Sir, this question.
This question, okay. The answer is B, is it?
Yes, sir. Leave it, sir. आपने ये करवा दिया, याद आ गया.
X square plus the formula will be
कोई लैम्डा वगैरह करना पड़ेगा.
X square plus Y square plus lambda X minus Y plus rho, basically that is rho, not P. Rho X minus Y whole square. So you have to expand it and you have to take the gradient. So C is obviously correct because that's exactly the formula in the slides, right? For the dual update. If you look at the slides, basically for the dual, the learning step size will always be rho. That's the special property of ADMM and method of multipliers. So lambda t plus 1 equals to lambda t plus rho will always be there. And inside the bracket will be the equality condition. X minus Y equals to 0, basically what is there. So C is definitely correct. For A and B, you have to write the equation and take the gradient. So somewhere I think the lambda sign will mismatch. That's all.
थोड़ा सा आगे एक देख लो.
Oh, okay.
एक That's why you do it. Okay.
Okay.
There's no issue, sir. I can do it. There is no issue.
Hmm?
Rest is fine, sir. I can do it. I
Okay.
want to.
Okay.
You did a lot for me, sir. Thanks a lot for this.
No, thank you for your interest. Best of luck for tomorrow.
Okay, thank you. Sir, एक और बात बोलूं? Sir, by the way, एक छोटा question आया तो मैं can I call you? Your number is also there in the mail.
I don't usually pick up. It's easier if you mail me. I check mail almost immediately. I'll reply.
Okay, done.
That's easier.
If there is issue. Otherwise, I will do it on the phone.
Okay.
Thank you.
Okay.